Good morning. Today we'll talk about logarithmic functions and exponential functions. We're going to do key attributes and transformations of them. So first we're going to start off with the logarithmic parent function. It can be written as log base 10 of x equals y, or sometimes you don't see the base 10. A log always has a base 10 if it doesn't have a number. So you can see the 10 and sometimes you don't, but these are exactly the same thing. So here it is in the calculator. So technically this graph goes down forever. It's never going to stop, but it actually is never going to be x equals 0. So there is an asymptote here. So it's never going to touch this y-axis. So my domain is going to be 0 to infinity. And 0 is in parentheses because it is an asymptote and it's never going to touch 0. So that is interval notation. In equality form, we can say 0 is less than x is less than infinity, or you can just say that x is greater than 0. So any of those are acceptable. I do interval notation most, so that's what you're going to see in this video. My range is going down forever, so it's going to go down to negative infinity. And it's coming up slowly here, but it is going to go up and it's going to continue going up. So remember, lowest point to highest point. Lowest is negative infinity, highest is infinity. We can also write all real numbers. So, and here is inequality form. What are my key attributes? What are some key things I need to talk about? So that there is an asymptote. There's an asymptote at the y-axis. There's an asymptote at x equals 0. So x equals 0, that is the y-axis. The other big thing here is that 1, 0 is my y-intercept. So those are two key things that are going to help us when it comes to graphing, when it comes to domain and range, is we're going to want to know the transformations of where did that intercept move to. Okay, so that's a logarithmic. So here are the transformations with the log. We have a, b, h, and k. And so the b is in front of the x. Now, if you have a b and an h, we're going to talk about factoring out that b. So this should be a summary. We've been doing transformations. So a causes vertical stretch or compression. If the absolute value of a is greater than 1, it's a stretch. If the absolute value of a is between 0 and 1, it's a vertical compression. And if it's negative, it's a reflection over the x-axis. B is the opposite. B has horizontal stretches and compressions, but if B is between, and its absolute value of B, if it's between 0 and 1, it's a stretch. If the absolute value of B is greater than 1, it's a horizontal compression. And if it's negative, it reflects over the y-axis. H is going to be in the parentheses. We're always going to change the sign. This will shift left and right, and K will shift up and down. So guys, because our range is all real numbers, this is not going to change my range. So even though K is going to make the graph shift up and down, it does not affect the range. Well, because my domain starts at 0, 0 plus h is going to be my new domain, okay? My new starting point for domain. So here's what we just talked about here. So transformations, what does a do? Now guys, when we're multiplying, a is always 1 if you don't see a number. B is always 1 if you don't see a number. H and K are zeros if you don't see the number. So let's talk about this graph. So the transformation here, this is just an a value. So a is 5, which means it has a vertical stretch of 5. Vertical stretches and compressions do not affect domain and range. All it does is it makes the graph grow more rapidly, okay? So my domain is still going to be 0 to infinity. My range is never going to change. It's going to be negative infinity to infinity. So my graph is going to start very low, and it's going to go up a lot quicker than it did. It's not drawn to scale. It's just going up a lot quicker than the original did. Okay. And because there was a stretch of 5, it did not intersect at 1, 0 because it intersected quicker. Okay. For example number 2, that is still an a value because it's in front of the log. So a is negative 2/3. So remember, we look at the absolute value. The 2/3 causes, it's a vertical compression of 2/3. And the negative means it's going to reflect over the x-axis. So guys, that one makes it a little bit trickier if you think about it. This graph, imagine this graph being turned upside down. So now it's going to come down and it's going slower than the other one because it was a compression. So compression pulls your graph closer to the x-axis, okay? So A does not affect my domain and range. So my domain and range are going to be exactly the same if I have an A value. So again, A does not affect domain and range. So here are a couple practice problems. Try them on your own. Go ahead and pause this video. When you unpause, your answers are going to be there. Okay, so remember that the parent function started at the bottom. Because this first one is a -3, it caused a reflection over the x-axis. And so that reflection means instead of it starting at the bottom, it started at the top. So normally it starts here, but because it reflected over. And it's going to grow quickly. Now I know we say quickly and it doesn't look like it. Well, remember that the original crossed right here. This crossed quicker, and this is growing a little bit quicker than the parent function, okay? Now, this one is a vertical compression. Vertical compression means it was growing slower. It didn't cross at 1, it crossed after, and it's going to grow slowly, okay? So either way, that whenever you cross the x-axis, it turns it almost like an L shape here, okay? And remember that A does not affect domain and range, so your domain and range are the same as the parent function. The B value will be inside of your parentheses in front of your x. And we did talk about horizontal stretch and horizontal compression, and we always take the reciprocal of it. And again, stretches and compressions can only be positive numbers. So if we see a -2, a -2 still means that it's a horizontal compression because we're looking at just the 2 value. And apologies here, this should be a horizontal stretch. So again, if we see that B is greater than 1, the absolute value of it, then it's a compression. If we see that the absolute value is less than 1, it's a horizontal stretch. And we always take the reciprocal. Now, a B causes a reflection over the y-axis, so this can affect your domain. So transformations in this first problem, that means that B is 5. B is 5 means that it's a horizontal compression by the reciprocal. The reciprocal, well, what's the reciprocal of 5? The answer is 1/5. So I'm still going to start at the bottom since there's no reflection. And a compression of 1/5 means it's going to grow slower than the parent function. And it's not going to cross at 1 because it is going a lot slower, okay? My domain is still 0 to infinity. My range is still -infinity to infinity, okay? And we are using parentheses on the 0 because it is an asymptote. On the next problem, my B is a -3. A -3 is a horizontal compression of 1/3. Well, what else does the negative do? It causes a reflection over the y-axis. So we're going to start at the bottom since it's not reflecting over the x-axis, but I used to start down here, but because it reflected over the y-axis, I'm going to start right here. And this graph is going to go up, and it's going to go this direction, okay? So now my domain, how far to the left is that graph going to go? So this is what can happen when you reflect over the y-axis. Again, 0 is an asymptote since my asymptote did not move left or right. And my range is still negative infinity to infinity. Okay. Now you go ahead and try 2 of these on your own. Go ahead and pause this video, and when you come back, the answers will be there. Hopefully you guys got these ones right. So b is 1/2, which is actually a horizontal stretch of 2. So a horizontal stretch kind of works like a vertical compression. Remember, a horizontal means it's trying to pull away from the y-axis quicker. Okay, a horizontal compression means it's actually closer to the y-axis. Okay, so how you normally cross is at 1. A compression means it's closer to the y-axis. That's for horizontal. Okay, these did not change my domain and range because there was no reflection over the y-axis. Okay. Now the h value. H value is going to shift left and right. It will be in the parentheses with the x value. Now because there's a negative in the equation, that means we're always going to change the sign of what we see. So this first equation right here, h is a positive 2. So the whole graph is moving to the right too. So let's talk about that. Where was my asymptote before? My asymptote was at x equals 0. Well, add 2. Now my asymptote, the line that it's never going to cross, is right here. Okay? So that's my basically where I'm going to start the line. So now my graph starts right here, and the graph is going to cross at 3 because even the intercept shifted to the right 3. So now, my h affects domain. H does not affect range. H only affects domain. So basically, my number used to start at 0. So it's going to be 0 plus my h. So my domain is going to be 2 to infinity. But guys, my range did not get affected. On this next one, my h is a negative 3. So this graph went to the left 3. So my asymptote went to the left 3. So this is where my asymptote is. I just want you guys to see that. So my graph now starts at the bottom of this graph, and it's going to cross at negative 2. Okay, so my domain went to the left 3. So my domain is negative 3 to infinity, and my range did not get affected. Okay. So now you go ahead and try these two on your own. Go ahead and pause the video, and in a couple seconds, the answers will be there. Okay, on this first one, the graph went left 1, which means my asymptote went to the left 1. This is an asymptote, so that line looks really, really close to it, but it's never going to touch it. And my y-intercept also shifted to the left 1. Okay, and again, it does not affect my range. So here was my original domain. Whatever my h is, I add it. So h is 4, so my domain is 0 plus 4, which is 4 to infinity, which means my y-intercept is 5, and the asymptote is x equals 4. Okay, k value shifts up and down. K value can affect your range, but if you have a range that's negative infinity to infinity, and you add 3 to that, what's my new range? It's still negative infinity to infinity. So even though my k value is 3, or negative 3, and the graph went down 3. So remember that my parent function started right here. I'm going to go down 3. 1, 2, 3. So now my graph is going to cross right there. Okay. But my domain is still 0 to infinity. My range is still negative infinity to infinity. So even though the graph shifts up and down, that shifting is not going to affect my domain or my range. So in the second problem, my k is a positive 4. So this graph is going up 4. So remember that we used to cross right here. Now the graph went up 4. 1, 2, 3, 4. The graph is going to cross there. So the graph is going to go slowly, 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 cross and turn. okay? My domain is still 0 to infinity. My range is still negative infinity to infinity, okay? Because k affects a range, but if the range is infinity, adding 3 to infinity, adding 4 to infinity is not going to change it. Go ahead and you answer number 3 on your and 4 on your own. Go ahead and pause this video. So hopefully these made sense to you. Guys, the first point I always plot, remember that I knew that this was a point of my parent function. If the graph shifted up 3, I shifted this x-intercept up 3. If the graph went down 1, I shifted the x-intercept down 1. Remember that it goes up slowly, 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 and when it gets to that point, it turns quickly, okay? Now let's be realistic. Most of the time, you're going to have multiple transformations in one. So we're going to just define the variables and describe the transformation. In this first problem here, we have a number in front of the log. That means that this is an A. This caused this graph to have a vertical stretch of 3. Now that negative 3 is not in parentheses. Therefore, this is my k value. K of negative 3 means the graph went down 3. On number 2, a number in front of the log means this is A. A is a negative 2. Remember that we only look at the absolute value to determine stretch or compression. So this is a vertical stretch of 2. Remember, you can only stretch or compress a positive number. So it's a stretch of a positive 2 with the reflection over the x-axis. And this is inside the parentheses. This means that this is my h value. We always change the sign of h. So h is negative 4, and the graph went left 4. Okay, question number 3. This is inside with the x. It's in front of the x, okay? So this is a b value of 5. When you have a b value of 5, that is a horizontal compression by the reciprocal. What's the reciprocal of 5? The answer is 1/5. So horizontal compression of 1/5. That plus 1 is not inside the parentheses. So this plus 1 is a k value of 1, which means the graph went up 1. Okay. Number 4, this 2 is inside the parentheses. That is an h value of a positive 2. So the graph is going to the right 2. That 5 at the end is not in parentheses. That is a k value of 5. That means the graph is going up 5. So now we're going to get into exponential functions, okay? So an exponential is the inverse of the logarithmic, okay? And we've learned that before. So remember that any time that you have an inverse, it is a reflection over the line y equals x, okay? So we had the logarithmic that started at the bottom and it went up until it crossed over, okay? So it used to cross over here and it went up quickly till it got there and it turned, okay? So it's going to be a reflection over y equals x. So let's look at just the red line. So the red line is the exponential. Now, my domain is going to be negative infinity to infinity. There are no restrictions on the domain because remember, the domain of an inverse is the range of the original function, okay? But now there is an asymptote on the range. What's my lowest range? There's an asymptote this time at y equals 0, okay? So remember that this can be written as negative infinity less than x less than infinity. It can also be written as all real numbers. My range this time is going to be 0 less than x less than infinity, or we can just say that x is greater than 0. Key attribute here, I have an asymptote. I have an asymptote at y equals 0, okay? And I have a y-intercept at 0, 1. So I'm not going to do as many transformations as the logarithmic. Same principles apply here. Now, this number can be any number. Now, because I'm doing the inverse of a log, what was the log base? It was a 10, which is why I'm going to do a 10 for these. But this could be a 2, this could be a 5, it could be anything. A is going to be in front of it. This number will be in parentheses if you have an A. So you could have a 5 parentheses 10, okay? B will be in front of your X. It'll be in the exponent. We are in exponentials. H is part of the exponent, and K will come at the end. So here are some questions we're going to practice. For this first question here, so again, this 10 is not going to be any part of our answer, okay? This is just my base. So this is an A value because it's in front of the parentheses. This is my H value because it's in the exponent, but we're always going to change the sign here. So A is 5, which causes a vertical stretch of 5. And H is -2, which is going to cause the graph to go left 2. For the next question, so H is going to be in the exponent, so this graph is going to go to the right 1. And the +3 is K, means the graph is going to go up 3. Okay, so H is +1, right 1. And K is a +3, so the graph is going to go up 3. On the next one, we have an A value. This -2 is going to be a vertical stretch of 2 with a reflection over the x-axis. There is no H in here, so this is a K value, and the graph is going to go up 1. For number 4, this is a B value. So B value of 5 means that it's a horizontal compression of 1/5. There is no H since there's no other number in the exponent, so this -2 is a K value. It's going down 2. Okay, now you can practice some questions on your own. Go ahead and try number 5 and 6 on your own. Pause this video. When you come back, the answers will be there. Okay, check your work. If you missed it or don't understand it, you can leave me a comment. Okay, go ahead and try number 7 and 8 on your own. Okay, go ahead and check those ones as well. Hopefully this video helped you practice some of the transformations of logarithmic and exponentials and have some understanding of the domain and range. If the video helped you at all, please give it a thumbs up, leave a comment. If you want more of these types of videos, go ahead and subscribe to this channel. Thanks and have a great day.